If you follow these simple steps, your oil consumption will stabilize and the piston rings will be properly seated. John Hazlett of Ameriflight Incorporated is a specialist in this process.
Prior to your test flight, always do a thorough pre-flight as Paul recommended. Pay special attention to cowling security, oil level and dipstick security, spinner security, the things that have been off the airplane for the engine change. Engine test flights should be conducted in daytime VFR conditions. New or freshly overhauled piston engines tend to run hot, so you should minimize your ground running time. Remember that carelessness at this stage can cause expensive damage. Coordinate with ATC so you can start up, taxi out, run up, and take off without lengthy ground holds. If necessary to hold, turn the aircraft into the wind and idle at 1300 RPM for maximum cooling. At this point, you can make a normal takeoff. We've moved to the Ameriflight simulator to better illustrate the following steps. Keep in mind that the speeds and power settings that we're using are for a Piper Chieftain. Be sure you use what's appropriate for your airplane. After takeoff, if engine RPM is more than 100 above or below the red line on the tachometer, if manifold pressure goes above expected values on turbocharged engines, or if other abnormal conditions are seen, heard, or felt, reject the takeoff and have the problem checked out by maintenance personnel. As soon as you're above obstacles, accelerate to en route climb speed plus 10 knots for improved engine cooling. Then reduce to climb power at 1,000 feet above ground level, but continue to carry the extra speed. You'll also want to coordinate with air traffic control so that you can circle over the airport until reaching 3,000 feet above ground level. This will allow you to make an immediate return if you run into a problem. After reaching 3,000 feet above ground level, it's okay to leave the airport area if engine operation is normal. But remember, the objective is to put some time on the engine and verify its operation. Don't stray far from home. If you have a problem and have to land at another airport, it could get expensive. After reaching a suitable cruise altitude, set normal cruise power and mixture for turbocharged engines. For non-turbocharged engines, the procedure is slightly different. In this case, we want to set 24 inches of manifold pressure, 2,300 RPM, and 1 gallon per hour below climb fuel flow. Once every 5 minutes, cycle the new engine prop twice up to red line, back to 2,200, and then reset 2,300 RPM. After 20 minutes at this power setting, set normal cruise power and mixture. You should use high cruise power settings for break-in, 65 to 75% of rated power. You don't want to baby the engine at this point or the rings won't seat, but keep an eye on cylinder head and oil temperatures. Let's talk for a moment about the steps you'll want to take prior to landing. At Ameriflight, we've developed a stage cooling program designed to reduce the engine stress associated with power reductions. Your aircraft is equipped with an air-cooled engine that's pulling a tremendous amount of power. Unlike the liquid-cooled engine in your car, where you can put the accelerator to the floor and then release it with minimal or no damage, your air-cooled engine reacts very differently to sudden power reductions. Abruptly reducing the power in your aircraft engine causes the various engine parts to cool off and to contract. Since these parts are made out of different kinds of metal, they'll contract at different rates, and this may... Now, regulating power reductions in a naturally aspirated or unsupercharged engine is important, but it becomes crucial with the turbocharged engine. The concept behind Ameriflight's stage cooling program is to reduce power in small increments in order to give the engine a chance to catch up. Here's how it works. Begin your descent at 500 feet per minute at cruise power. Cause them to crack under the stress. Every 1 to 2 minutes, reduce manifold pressure in small increments, 2 to 4 inches. Keep repeating this process until you've reached the power setting for traffic pattern entry or final approach. Remember, our main concern here is to avoid abrupt, large power reductions, so in addition to a safe landing, you'll have a sound engine at the conclusion of your initial test flight.